Hello students, welcome to Samir math classes. Last class we have already completed types of function, that is injective and surjective function. Today we will continue from that is from bijective function. Don't forget to like, share, comments and subscribe the channel to get the updates. Let's start from bijective function. Bijective function. Bijective means two. If a function is both injective and surjective, then it is known as bijective function. A function f maps from x to y is said to be bijective if it is injective, and surjective. Okay. After bijective function, then we'll go for invertible function. Bijective function will got invertible function. Invertible function. Invertible function means if the inverse of a function exists, then we say that it is an invertible function. That means what is invertible function? If the inverse of a function is itself a function, then it is known as invertible function. That means the inverse of a function may or may not be a function. Those functions whose inverse is a function are known as invertible function. To get an invertible function, then all functions does not exist its inverse. Only which type of functions has inverse? Only bijective functions have inverse. So direct we can say that a function f maps from x to y defined by f of x is equal to y is said to be invertible, if it is bijective. That means if the problem comes that the proof that the function is invertible, just you have to prove that it is a bijective function, that is injective and surjective. And the inverse f inverse maps from y to x. That means if f maps from x to y, f inverse maps from y to x defined by f inverse of y is equal to x. Okay, that is the definition of invertible function. We'll do a problem. Example, let f maps from R to R defined by f of x is equal to 2x plus 5. Prove that f is an invertible function and also find f inverse x. f inverse x. Okay, do this problem. Solution. To prove the function is invertible, we have to show that it is a bijective function. That means we have to show that it is injective as well as it is surjective. So here f maps from R to R defined by f of x is equal to 2x plus 5. To prove f is an invertible function. That is to prove it is a bijective function. It is a bijective function. Means injective and a bijective function means injective and a surjective. That means if you show that this function maps from R to R defined by such way, if you prove that it is an injective and surjective, then it is an invertible function. First we will prove it is an injective function. First prove kariba injective. To prove a function is injective, we have to take two different elements from the domain and let x1 comma x2 belongs to DOM F, that is R, such that f of x1 is equal to f of x2. We have to show that x1 is equal to x2. So that implies here f of x is equal to 2x plus 5. f of x1 about 2x1 plus 5 is equal to 2x2 plus 5. 5 cancel. That implies it 2x1 is equal to 2x2, implies that x1 is equal to x2. x1 is equal to x2. Hence, f is injective. Rest, we have to prove that the function is surjective. For surjective, we have to show that the domain of the function should be equal to its range. That means every element of codomain will be equal, will have a pre-image in the domain set. The surjective, let y belongs to codomain f, that is codomain is here R, such that f of x is equal to y. It indicates that randomly we take an element y from the codomain, let's its pre-image is x which is in the domain. We'll search for that x in terms of y. That implies, but f of x is given as 2x plus 5. In place of f of x, we can write 2x plus 5 is equal to y. We are searching for x, that means 2x is equal to y minus 5. That implies x is equal to y minus 5 by 2. y minus 5 by 2. Which that for every y in the codomain, which belongs to DOM F. So F is surjective. Since F is injective and surjective, so it is a bijective function. Since it is bijective, so it is an invertible function. Since f is F is surjective and injective. F is surjective and injective, so it is bijective. So it is bijective, and hence it is an invertible function. It is an invertible function. Now F inverse maps from y to x. Here F maps from r to y, matlab x is r, y is r. F inverse is also maps from r to r to r, defined by F inverse of y should be equal to x. But here pre-image of y is equal to x, which is equal to y minus 5 by 2. So we can say that implies F inverse of y should be equal to, in place of x we can write y minus 5 by 2. That is the inverse. In general we can say that F inverse of x is equal to x minus 5 by 2. This much. Over. That means if f is equal to 2x plus 5 is an invertible function, then f inverse x is equal to x minus 5 by 2. Another important problem we can do, that means since the function is, if it is the invertible, then it must be injective and surjective. For injective, the domain of the function is responsible. For surjective, the codomain of the function is responsible. We'll do another problem. So that's an important problem for board examination. So that F maps from R to R. F maps from R to R defined by f of x is equal to x square plus minus 1 is not an invertible function, is not an invertible function in general. Find the next question. Find the domain and a codomain. Find the domain and codomain where f is invertible. Where f is invertible. Also find f inverse x. That means solution is here. First understood the question. Here f maps from R to R. That means the domain of the function is given a real number. Codomain of the function is given a real number. For invertible, function must be bijective, that is injective and surjective. For injective, the domain of the function is responsible. For surjective, the codomain of the function is responsible. Here the function defined by f of x is equal to x square plus minus 1 is not an invertible function. That means here with respect to this domain and codomain, the function is not invertible. That means it may not be invertible or may not be injective or may not be surjective. Then you have to find or decide for which domain it is injective and for which codomain it is surjective. That means for which domain and codomain the function is both injective and surjective. That means the function is bijective, implies that the function is invertible function. We have to find out that domain and codomain. After that, we have to find out f inverse x. Let's start. Here, f maps from R to R defined by f of x is equal to x square minus 1. For invertible, it must be injective and surjective. Let's check whether the function is injective or not. First, we have to check that injective. Let x1 comma x2 belongs to DOM f, that is R, for which f of x1 is equal to f of x2. That implies x1 square minus 1 is equal to x2 square minus 1. Minus 1 cancelled out. x1 square is equal to x2 square. That implies x1 is equal to plus or minus x2. That implies x1 is equal to x2 or x1 is equal to minus x2. Here, two conditions arise. For injective, we have to take two elements from the domain, that is x1 and x2, for which f of x1 is equal to x2, and if you show that x1 is equal to x2 is the only one condition, then the function is said to be injective. Here there are two conditions, x1 is equal to x2 or x1 is equal to minus x2. If you restrict the domain, then the other condition is x1 is equal to minus x2, which is satisfied the respective domain. That means if you take x1 is equal to 2, x2 is equal to minus 2. Suppose domain is here. If you take x1 is equal to 2, then x2 is equal to minus 2. Here f of 2 will be equal to 4 minus 1, 3. F of minus 2 is also 4 minus 1, 3. That means the two different elements in the domain has a same image. So it is not injective. But if you restrict the domain in place of R, that is, we neglect the negative real numbers. That is, if you restrict the domain from here R is equal to minus infinity to plus infinity, that is 0 to infinity. If you neglect the negative real numbers, that means if you neglect the negative real numbers and restrict the domain from 0 to infinity, then it will be injective. No other condition will satisfy. Here we have to write it as but x1 is equal to x2. The only this condition is valid. x1 is equal to x2. Only this condition is valid. Only this condition will valid if we restrict the domain as 0 to infinity, that this much is closed and this is open. Now here the function and the function will be, and the function restrict the domain as the function will be injective. The function will be injective. Okay. Now in place of the domain R, the domain will be 0 to infinity. Let's go for the check for surjective. Go for surjective. That is surjective. Surjective means let y belongs to codomain F. Codomain F, that is R. Codomain F, that is R, such that f of x is equal to y. that implies x square minus 1 is equal to y, x square is equal to y plus 1, x is equal to y plus 1 root over which does not belongs to DOM f for y less than minus 1. But if you restrict the codomain, but if we restrict the codomain as minus 1 to infinity, then it is surjective. Hence, then it is surjective. Hence, if f maps from if f maps from 0 to infinity with this domain and codomain is minus 1 to infinity, then f is both injective and surjective, that is bijective, and f is invertible bijective, hence f is an invertible function and invertible function. Now f inverse maps from minus 1 to infinity close open towards 0 to infinity open close, defined by f inverse of y should be equal to x. That implies f inverse of y is equal to y plus 1 root over, in general, f inverse of x, in general f inverse of x is equal to x plus 1 root over root. Okay, this is all about invertible function. The next class will continue from composite function. Today's class is this much. Thank you.